Hi, everyone. I'm Tim Mishak. I'm here today with Mario Hewardt, who I'm really excited to finally get a chance to talk with. Mario has literally written the book on WinDbg, and strangely enough, our paths haven't really crossed until now. Mario reached out, and I jumped at the chance to record a video with him. We could talk a little bit about what he's done and some other stuff like that. So, Mario, welcome to the show.
Oh yeah, cool. Thanks for having me, Tim. And yeah, like you said, it's interesting how um, the awesome work that you did as a dev lead over there in the native debuggers, WinDbg and or WinBag, and the work that I've done that we haven't gotten a chance to sync up. But yeah, that was awesome. Yeah, for sure.
Yeah. So, I think some folks watching may have read your book, but you've written at least three books, right? You've written Advanced Windows Debugging, Advanced .NET Debugging.
Yeah, well, so two books, but I also have some like some pluralsight courses, video courses.
I see. Okay.
Yeah. Um,
Okay.
but yeah, that's been a lot of fun. I in one very short month, I am celebrating a quarter of a century at Microsoft. So
Oh, wow.
25 years in July. So I've been here for a while. But and I've also been sort of in a lot of different roles at Microsoft. Like when I first started, it was well, what were we called back then? Software design engineers. That's what it was, right?
Right.
So that's the equivalent of software engineer today. Um, and I was always when I started, I was always very very close to sort of the low level parts of Windows. I worked on a team called WMI, Windows Management Instrumentation, um, and so I spent a lot of time there, and then after a little bit, I've figured I want to kind of change course a little bit, and instead of working on these server type of applications, because WMI is about Windows, management instrumentation and all that. I was like, I want to go and do something different, so I went and uh, I went to Windows Mobile, um, and I spent some time there working on some pretty cool stuff. That by the way, Windows Mobile, that was that predecessor to the cool thing, Windows Phone, right? So it was in before Windows Phone. Um, and then after that, I came back, from the mobile space, and I decided to see what was going on, sort of back in the infrastructure management space again. And uh, Microsoft had just acquired a company that became the sort of precursor to Windows Intune, and so I worked on that for quite a few years. And then once again, I switched. And this is one of the great things that I love about working at Microsoft. Like it's a big company, and people are like, well, how can work in that type of environment? Is like I can literally go and do different things and grow that way. So I love that part of it.
Yeah. I always would sell people on this idea of like it's a big company, you can go and do lots of different things. And then, my career, I stayed in one spot for 15 years. So,
Okay. Yeah. Well, it's. I mean that can definitely happen. I mean, I didn't sort of job or position up whatever you want to call it Microsoft every year. Like I stayed for a good chunk of time every before every move. So and the other thing I want to mention is like it's not like I went from being a software engineer to being to something completely different. It was always software engineering. It's just in slightly different organizations, basically. But yeah, so then I went over and I actually went to the field, which was great. It's a great way of learning how our customers work with our software and what we can do, to make them better. About 5 years ago, when I was in the field, right, one of the things that I was trying to think about is what is coming down long term here, in terms of things that might be interesting to us in the field. And one of the things that came up was diagnostics. I did a ton of diagnostics in my field role. I mean, even before that. But one thing that sort of made me a little bit um, one of the challenge that I saw is that Azure, which is an open platform, you can go and you can bring Linux and you can run your workloads on Linux. And so that's kind of one of the things that I was like, well, how are we set up to do things well on Linux in terms of diagnostics, right? And so I decided to go on this quest of thinking about what are some of the diagnostics tools that we have today on Windows that could possibly make sense on Linux. Like, we're not going to
Mhm.
just start porting things just because we're porting them. What makes sense, right? And so I looked at the Sysinternals tools, and I saw that there was some opportunity there to plug some gaps and make it a pretty interesting or appealing scenario. And so that kind of what I started doing back about 5 years ago, and I've been working on that for a while. And then recently, about a year ago, I was spending most of my time on the Sysinternals for Linux tools, and so it just made sense that I would kind of move full time back into uh, the Sysinternals team, which is under the Azure Office of the CTO. So that's the long story. The whole thing here, my thread throughout this entire thing, has been diagnostics and debugging. Like, I'm so passionate about that. As you know, if you write a book about it, you got to be super passionate about something. Let me tell you that. um,
Yeah,
but
yeah,
that's sort of been a super huge thing for me. I love it, and I think sometimes people misunderstand me because they're like, "Well, how could you possibly love the debugger? Because the only time you use it is when you make a mistake and you have to figure out your own problems." Whereas I view it clearly, I write buggy code just like anyone else, and I will use a debugger, but I use it most of the time as a window into the underlying abstraction, whatever it is that I'm working with. So whether that's Windows or if it's the .NET runtime or anything else, right? These debuggers give you this awesome view into it, um, and that's what I really kind of love about it is um, how you can have that view and use that knowledge to then troubleshoot some really challenging problems.
yeah. I mean, that's one of the things I love about debuggers is not necessarily even debugging, but using it as a tool for exploring.
Hmm.
And I think there's just so many things that I've learned just by using low level debuggers that I don't think I would have learned, or at least it would have been a lot harder to learn otherwise. But you're right, though. Like, a lot of people have this way of thinking about debuggers of like every time they're using it, they're angry because their code is broken, maybe, or something. And of course, that reflects in some of the feedback that we got, on WinDbg, and you can tell sometimes people are just, you know, when your debugger fails and you're debugging something that's a really hard problem, it's really the last thing that you want to do. And so, I totally understood. Like, that's how some people saw debuggers, is like, I'm angry when I'm using the debugger. But I'm with you. I love when I'm in a debugger because I'm exploring code and I'm learning new things. That's kind of how I see it.
Yeah, and I think one other quick thing too is like when you sit down and troubleshoot some really challenging problem, and you've been looking at dumps for 2 weeks, 24/7, and you finally get to that root cause, um, you're not going to make the same mistake, whether it's yours or not, right? But you're not going to make that mistake. So it does help you also grow, I think, as an engineer.
Yeah, there's kind of a weird aspect of, as I've gone through my career, early in my career, it was a lot of C, C++. Later in my career, I was using a lot more .NET. And these days, most of the code I'm writing in is Rust. And there's kind of this weird aspect of like, there are certain class of, memory safety problems and other things that are just not not nearly as prevalent, or sometimes completely eliminated. And there's part of me that like weirdly misses debugging some of those problems. Of course, now we have completely different types of problems we have to debug, but it's kind of interesting to see how things have sort of shifted. And of course, WinDbg's still useful for .NET debugging, of course, for some cases, but there's different types of bugs now. Completely different class.
Yeah, yeah, yeah. I think the landscape with, I mean, Rust is obviously a major player, but there are so many languages popping up now trying to sort of find their place in this whole spectrum of software engineering, right? And but I do agree, like as much fun as it is to debug a heap corruption, we should probably not have it to begin with. I think that's probably a useful thing. um, uh, but yeah, but then there's also the notion of, and all of these languages, they at some point or another they're gonna have to thunk down into some unsafe mode, and then um, you still might have some issues that you otherwise wouldn't expect.
Yeah, absolutely. Something you mentioned earlier that I thought was really interesting was that you said about 5 years ago you started working on, looking at what Sysinternals tools and other diagnostics tools would make sense in the Linux world. And it's kind of funny because looking back, I think that pretty much aligns with when the debugger team started shifting a lot more towards the Linux space. I don't remember the exact timing, but I remember we had a conversation with some folks. We had a conversation with some folks in Azure, conversation with some folks working in the kernel side, and just realizing that, of course, Azure is a huge part of Microsoft, one of the largest parts of Microsoft. And the amount of Linux that was just going to be important for Microsoft and for the industry, it made sense for us to look at what parts of the things that we're good at should we be bringing into this. And, I might be a little bit biased in saying this. I think Microsoft's strengths, one of the strengths has always been diagnostics. I mean, it's kind of like in Microsoft's DNA. You look at how early things like debuggers were written in debugger extensions. And of course, there's this huge library of debugger extensions that have been written by engineers over the past 30 years, right? And so that was something where I saw, I think Linux kind of was lacking some of the diagnostics infrastructure that we took for granted inside Microsoft for so long. And so I think it's been really interesting to see the decisions that people make in terms of what tools make sense to bring over, what makes sense to sort of, contribute on the Linux side, and where it makes sense to sort of not have this Windows-centric view of diagnostics and debugging. And of course, I think that's still evolving, right? But just, I look at what we did with WinDbg, and it was all Bill Messmer's work really to bring a lot of the Linux support into WinDbg. And there are people that still will say on Twitter, like, WinDbg is a better debugger in some cases than GDB, right?
Yeah.
Of course not in every case, but there's some weird cases where you're like, yeah, WinDbg does better than GDB for debugging this crash dump. It's kind of weird. Or this Linux
On
core dump,
Linux.
Yeah, yeah, yeah.
Yeah.
So it's been interesting to see a lot of this shift, and of course the .NET team as well, and other teams at Microsoft have been doing a lot more work on Linux and diagnostics and
Yeah.
Linux and stuff.
Yeah, and it's really interesting. When I first thought about like what should we do in terms of the Sysinternal suite is huge, right? It's got a lot of tools in it. You know, a ton of customers are using all kinds of different things, and so I wanted to kind of do a proof of concept, figure out number one, what is the Linux community going to say about Microsoft coming in and going sort of into the diagnostic space a little bit, and so we chose to use ProcDump. I'm probably aware of it. You can generate crash dumps off of processes based on certain triggers, right? So that's the one that we chose, and we started pretty small. We just implemented a couple of triggers like CPU and memory thresholds, and it turned out, it was really well received, and which was great for us. And we then kind of continued with adding some more stuff for ProcDump, and then we um, switched gears a bit and did ProcMon, and then I guess a couple of years ago we also did the initial version of Sysmon. So yeah, it's been pretty good. It's been really interesting and nice to see how people react to these diagnostics tools coming from Microsoft, running sort of natively on Linux.
So when you started looking into Linux diagnostics, and started looking at some of the Sysinternals tools, I don't know, did you see it more as porting or bringing entirely new tools in?
I think that's a great question. I think it's a little bit of both, to be honest. Like, I don't want to call it a porting exercise, but I don't want to necessarily call it a brand new thing either. So it's something in between. Maybe we can come up
Mhm.
for a word for that. But um, like one example is, for example, Procmon. If you've used it on Windows, it's collects a whole bunch of stuff and has a very fancy and beautiful UI that allows you to do all kinds of querying and filtering and all kinds of stuff like that. What we found though in the Linux world is that most IT admins, they just kind of sit in SSH and do their thing in a terminal, and so sort of going from that super powerful GUI way of doing things and then representing the same vast information onto a shell using a TUI in the case of what we did, was really, really challenging, right?
Hmm.
So that's just kind of one example, but by and large, I think the diagnostics community, um, I I don't think that there was honestly a ton of difference sort of between the Linux mindset and the Windows mindset. I mean, there's of course the usual things like Windows is turnkey, Linux command line tools are like super super small. They do one thing really really well, and then you just string them
Hmm.
all together with 1 million of them, and you get this massive result. So we're trying to, of course, uh, honor that and use the same mindset for those type of things. But by and large, diagnostics, I think we just I think people just got it, and it was there wasn't any sort of huge thing.
Yeah. Do you find more of the folks that are using the Linux sysinternals tools are folks that are familiar with sysinternals on Windows, or they're more Linux folks that are finding that sysinternals stuff is useful for them and stuff that maybe they haven't used the Windows versions?
That is a great question. I can't give you a definitive answer on that. But what I can
Yeah.
tell you are the signals, some of the signals that I've seen, and
Mm,
there's definitely people in the Linux community, like not coming from Windows, that are using our tools. ProcDump is hugely popular. Um, there was like when it came out, it was like some Hacker News article coming out about it. There was a ton of comments and discussion around it, which was great. Um, but there were definitely some Windows engineers that were like, "Hey, I've used it before, and so this is a great, easy way for me to do stuff in Linux." But there were definitely Linux engineers that were there as well, and they're using them. Yeah, I don't know what the
mm.
breakdown is necessarily, but this is both.
I've switched almost entirely from my day job being Windows to Linux,
Hmm.
and I've only just started using some of the sysinternals tools. But I do feel like it's kind of a little bit of shift of how I have to think about some things. And I know when we were doing Linux support and WinDbg, we definitely had two sets of people. One which was I know how to use WinDbg and I just want to use the tool that I know now that I have to do some Linux work. And then there was the other set of folks that were, natively, coming from Linux tools and were like, can you make WinDbg look a little bit more like GDB? Like, can you put like commands in there? Um, so it was kind of an interesting split between those two groups. Um, and yeah, I don't think we ever really figured out like which was the right way of thinking about it for WinDbg. But at least at Microsoft, most of the people that were using it on Linux were things where it was like, okay, it was cross-platform, so let's not make people learn different commands and stuff like that.
Hmm.
Um, so it's interesting, and yeah, I haven't actually used the Linux versions. I've used the Windows versions of the sysinternal stuff a lot, so it'll be interesting to see if it's a learning curve for me to
Yeah,
use the Linux versions.
and just full context, this is a learning experience for us as well, right? I mean, bringing
Yeah.
diagnostics tools over to Linux, and um, we're open to any and all feedback, obviously, to see what we can do better or what we can change. So definitely.
So you've been in diagnostics for a long time. Um, have you seen things like? Have you seen any things that have shifted over time, or things that you think are shifting now in terms of how we look at diagnostics?
I think I would have to kind of categorize diagnostics in the context of this question anyway into kind of buckets, which is one is the low level debugging type of a thing, versus maybe the more higher level debugging, like inner loop type of things, right? And in the latter, I've seen a ton of innovation. Like if we look at Visual Studio and the debugger in there, it is massively um, feature rich. It can do a ton of stuff, right? So I've definitely seen a ton of improvement in that part of the diagnostic space. When I when I think about the latter though, which is or uh, the low level debugging, like WinDbg and all these things, it's there's obviously been investment and there's been some really really great work, including the work that you did with WinDbg Next, which is awesome, right? But when I think about like uh, kind of like 20, well, I don't know how long ago was it, 20 years ago, whatever it was, when I first decided to write my books. It was because um, we had new hires come in, right? They would go through Neo, new employee orientation, and the next morning they finally got their email set up, and in the email they had 17 KD remotes, and they had no idea what the heck they were doing, right? External
Yep.
hires,
Yeah. Yeah.
um, and and so that was kind of the motivation. We maybe we'll talk about the books a little bit later, but point being, I think that in terms of like the KD that we used back then and the KD that we're using today, outside of extensions that have evolved, obviously, I think we're pretty much in the same kind of spot that we were a long time ago.
Yeah.
It's a space that's really really challenging um, to do a ton of investments in because people don't necessarily think they need it until they need it, and then when they need it, they really 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 need it, right? Um,
Yeah.
so that's kind of, I don't know if that answered kind of your question or not, but
Yeah. My perspective from the WinDbg side, there was always a bit of a push and pull between the folks that had been using WinDbg for 20 years, or not necessarily WinDbg, maybe KD, right, for 20 years, and changing small things would, would break their flow. And of course, there are, XKCD jokes about this, about how, people rely on these little different behaviors, as well as trying, on the other side, trying to make things usable for folks that, like you said, they just came from Neo and they've got KD remotes sitting in their email, that was me when I first interned on Windows Vista, and that's daunting to see that. And so weirdly, yeah, WinDbg has in some ways just not changed for 20 years, partly because some of those things had to continue being sort of similar. And that was one of the reasons why I was trying to think from a different perspective of like, let's not change the old stuff, but let's at least sort of streamline some of these things. In a sense, right, it's still kind of the same thing. And I don't know what we're going to see sort of that next step for it to be actually different. I did see there was an announcement at Build. There are folks that are looking into using AI with
uh-huh.
debugging, with WinDbg specifically, which I think that's really exciting. And I don't know what form that's going to take, but I think there's definitely something there. It's going to be interesting to see what folks at Microsoft and outside Microsoft come up with respect to that. Um, but but yeah, like to your point, WinDbg is kind of, it's been very very similar for a long time. Even with some nicer streamlined things, it's still very similar workflows of like how you work through problems and debug things.
Yeah. No, I do like the in terms of what might be coming, down the pipe in terms of um, Chat GPT, AI, LLMs, all these things, right? I think there's definitely a big opportunity in the diagnostic space. If if we're able to sort of train the AI on certain very common patterns, and with the context that it might have, whether that's a log or it's a dump, it doesn't really matter, right? But the context that it does have, I think it can really help um, engineers get to root cause a lot faster than than we do today. Let's say on average, you have a production issue and you get a call stack, right? And it's a SQL failed to connect type of a call stack. So what is first thing people you jump onto Stack Overflow and you start searching there, and you get a whole bunch of results, and you're like, well, this kind of looks like it's kind of the same thing as mine. And then there's a whole bunch of talk around it, and they say, well, it could be this or it could be that. And then you go back to your dump or log and you start digging a little bit more and picking out those things. You go back and forth, back and forth, back and forth until you finally get sort of like, yes, this is definitively what's happening. And I think the AI can really, really automate all of that and make it much, much more efficient. Now, do I think that an AI today can solve a really, really, really nasty heap corruption? Probably not. But I think with time, it can get better and better and better, and it can really help us be more effective.
Yeah, I think there's, you know, a lot of the advancements in some of these things have not been that, every class of problem is made better, but it's been there's a certain class of problems that go from being you have to have a whole bunch of knowledge to maybe we've automated through that. I look at Bang Analyze as one example of this of trying to very in terms of rules, codifying how to find the fault in a failure, try to find the blame frame and things like that. And I wonder if some of the stuff that maybe we might be able to see is maybe it's not going to figure out that heap corruption for you, but it's going to, rather than having to know a very specific debugger extension that grabs a very specific piece of data out of some internal structure, to maybe that's going to be the sort of thing that will be able to have enough information presented that a large language model could go in and figure out at least what's the right pieces of data to look at. And that's something that I never felt we really succeeded on, of trying to get the right data in front of people, even if we're not necessarily solving problems for people. Finding the right information was a hard problem from a user interface perspective. Even
Yes.
there were my PM at the time, I think, went and actually counted the number of debugger extension commands, and it's a mind-boggling number of commands. I think internally there were, I want to say there were like 5,000 commands. I'm pulling that number out, but it was a huge number, and of course nobody knows all of them, right? And you're not going to necessarily know the right command at the right time. So it'd be great to see if there are, great to see some bigger leaps towards actually doing analysis and drawing some conclusions and maybe even some root causing. But hopefully we get to a point where we can at least get some of the right information, um, based on previous debugging sessions or based on documentation or things like that. I think that'd be really neat.
Yeah. I mean, if I got to think about any given debug session that I've done, when I'm done actually investigating it, and I look at how much of the diagnostics data that I really needed to get to root cause in comparison to what I've collected, I mean, it's tiny.
Yeah.
And I think that's kind of one of the big things is how do we help engineers navigate this vast amount of diagnostics data and just showing what's most important based on what we're seeing. Yeah.
Yeah. Some of the things that people like the most in some of the stuff with WinDbg were things that let you see patterns easily, whether that was giving people information in a grid view where you had a tree view before, which seems kind of like a very simple thing, but when you can see patterns and see the information, or even the highlighting feature in WinDbg where you can control double click on a number and then highlight every other instance of that number. Just being able to see patterns, I think, was kind of an interesting thing. So that's something that I think there's potential for, just because large language models are good at
Yep.
finding patterns and things like that. So hoping we see some innovation there and see some leaps.
Yeah. I mean, it's super exciting with that push that's going on around all these things, and I definitely see big things can be happening for diagnostics as well. So it's super exciting.
Yeah. Besides the obvious, like the AI models, are there any other technologies you're excited about that, maybe with respect to diagnostics?
I mean, I think in terms of the big picture, the AI bucket is the big one.
Yeah.
There's always going to be interesting technologies that come and go um, for Sysmon, for example, for Linux. As a matter of fact, even Procmon for Linux, we use a newish technology in Linux called eBPF, and it's a sandbox way to run user mode code in the kernel. And without having that, we wouldn't be able to do what we wanted to do with Sysmon or Procmon. Um, and that's been taken off really kind of in a big way in the last few years. So eBPF was a really exciting one on the Linux side. Um, outside of that, I think we just kind of do what we do to kind of keep status quo. But AI to me is the big one. Um, I think, and one challenge that we have that we should probably talk about this one, um, the cloud, right? Um,
Hmm.
Whether you're on Azure or AWS or Google, doesn't really matter. If you're using any kind of PaaS services, platform as a service, where you don't have access to the underlying VM or machine, as a matter of fact, you don't even know that it is a machine, right? If you're running your app in infrastructure as a service, like a VM, you can install WinDbg all day long and just do what you did before. In the PaaS scenarios, though, it's really interesting because how do you, like, let's say that you had one of these big nasty issues like a memory leak or a heap corruption. How do you begin to analyze that? You can't just randomly somehow tell WinDbg go and point up somewhere to Azure and um, you know and attach and do your debugging. So I think one of the interesting parts of this is how do we expose um, existing capabilities that we know folks use, and how do we expose them through the web interface so that they can do the same things in their platform as a service applications. I think that's another kind of big thing, and I think um, until we get to a point where we have close to feature parity with on-prem or in IaaS, then it's a challenge, right? How do we enable any arbitrary number of diagnostic scenarios uh, for a platform as a service application without exposing a full-on debugger, right?
Yeah.
So I don't know if there was those are some of the things that you all might have been talking about with WinDbg, but it is a challenge. I think we're doing pretty good. Like, for example, app services, we have Kudu, and Kudu has grown quite a bit with the diagnostics blade in the Azure portal. So you can do quite a bit of things, including getting crash dumps, restarting automatically, and there's quite a bit of stuff in there. Um, but it's a catch up. Like, we have to play catch up on those things.
Yeah, I know as I've started doing more service development and less application development, I've had to change a little bit how I think about diagnostics. Um, and so much more of what I do is based on logs. And,
Mm-hmm.
I've learned about things like structured logging and stuff like that that have really made my life easier. But it seems as if there's still kind of and I don't know all of what Azure has here. It seems like there's still some opportunities for bringing some of the stuff that we took for granted, or I took for granted back doing application development, of being able to grab crash dumps at an arbitrary time. And of course, there are systems now you can go and grab crash dumps and at times, but there might be some opportunities for more of these hybrid things. I know that there are companies that do some of these things. I think Honeycomb has is one of these companies that's doing some interesting things where it's kind of they have some of these hybrid capabilities between sort of logging and traditional debugging. Um, but uh, I think it's challenging when you want to look at a production system. That's
Yeah.
always a really hard one. You can't just step through code like you could before, um, which at least if you've got a Windows code, I know this is something that the time travel debugging team was really dreaming of being able to do, was capturing time travel debugging traces in production, which I think would be a really cool thing to do.
That would be
Um,
awesome.
yeah, that'd be awesome. It would be interesting to figure out how you could do that without taking down production, without taking that 10x 20x slowdown.
I mean, speaking
Uh,
of sort of like the uh, North Star kind of a question, like, if we can make time travel debugging be the default experience, I'm like,
yeah,
and I know we have it.
yeah.
It consumes a lot and a lot of overhead, but like the North Star, if we can get that, the uh, the amount of engineering resources we would save is amazing.
I think of the things where, sure, I'm doing a lot more log debugging, but it'd be great if I can say, point at a log message and be like, yeah, I want a TTD trace from this,
Yeah,
something like that. Stuff like that, I think
it'd be awesome.
that'd be great. Yeah. So tell me a little bit about writing the WinDbg book. the Advanced Windows Debugging. I shouldn't say it's not the WinDbg book. WinDbg is part of it, right?
Yeah.
Um, so were you already at Microsoft when you wrote this book,
Yes.
or had you not joined yet?
Nope. I had been in Microsoft for 5 years.
Okay.
Yes. So going sort of back to the Neo for new engineers and being greeted with the nastiness of a bunch of KD remotes, that's kind of what I was struggling with. Not, I had already been in Microsoft, so that I'd already done a lot of that. But for the new hires, right? It was a big challenge because we would have to end up sort of doing kind of over the shoulder teaching. Someone would get a KD remote and be like, "Well, I don't get this part of it," so you walk in there and you help them out, and you try to sort of teach them the things that they needed, and then you would have to answer the same question like 3 or 4 other times. So it didn't really scale. And um, one, I mean, I guess this is the only time a rainy Seattle commute ever contributed to anything useful. It was super heavy rain. Traffic was just standstill, and it was like 2 hours to get to campus. That's what I was thinking about. Is like, we can't keep doing this. Like, we're losing so much time on just trying to educate engineers on how to do these things. And so that's when I started thinking about it, and I was trying to find a solution to the problem, and a number of things went through my head. The book was the last one that went through my head. Like, I never set out to write a book. English, as a matter of fact, is not even my first language. So, um, but I entertain ideas like, can I write some blog posts, or like, internal blog posts, or do some videos or whatnot. But I felt that in order to have, I felt that what would really solve the problem would have an end to end learning experience. And blogs sometimes assume too much, or video trainings assume too much. A book forces you into that mindset of, this is end to end. Um, and and that's sort of how I came up with the idea of doing this. Just it was
Hmm.
there was a problem, and in terms of how we can optimize things, and the book seemed to be the right thing.
Yeah. Had you spent time, teaching people to use these tools before you wrote the book?
In those isolated things, like on the team,
Yeah.
when someone new would come in, right, and person 1, 2, 3, and 4 doing the same thing for all of them,
Yeah.
and that
Asking the
was
same
exactly,
questions.
that was the same problem
Yeah.
that I was trying to solve.
Hmm.
So that's kind of how it came about.
Yeah.
Scary. It's if if the first time that you decide that you want to do this and you want to get published, um, it is somewhat of a scary thing. You're putting yourself out there, and if your book ends up getting 1,000 one-star reviews, then that's something that's going to follow you around, right? But I felt that the problem was bigger than anything else that needed to get solved. And I strongly believe that this was the right way of doing it, and it turned out really well. Um, at least, based on reviews or whatnot. So people seem to enjoy it.
Yeah.
And then I think after that, because the advanced Windows debugging um, was really successful, people started asking about, well, I don't write Win32 apps. I write .NET apps. So, is there anything that you can do for that? And I had also been doing a lot of diagnostics within the CLR and the runtime. So that's when I wrote the second book called Advanced .NET Debugging. Um, and that sort of talks about how to use WinDbg in coupled with SOS to
Hmm.
debug, right?
It's kind of a daunting thing to think about how to teach people how to use some of these tools. Um, I had lots of people that would ask me to do like WinDbg 101 talks, and I used to do them, and I never really felt like they were very successful, partly because um, you can't take an hour and teach people to use. I mean, I can give you like, here's how to go collect a crash dump, here's how to go and attach your process and these things. But there's such a huge number of different scenarios and ways that people need to use a debugger that I would find in every crowd there would be just a number of groups that had almost completely distinct use cases, whether it was the folks that did just .NET debugging, or the folks that did kernel debugging, or the folks that were, support engineers and didn't necessarily even, didn't write the code, or maybe didn't even have source code for the things that they were debugging. So it's just kind of and that's not even specific to WinDbg, just teaching debugging concepts in general is just, it's kind of a lot, teaching new devs just the debugging techniques and stuff. It was really hard to come up with how do you rush this experience of knowing how to recognize these things. And I could teach you how to use the tools, and I can tell you to go read the book, but it's it's a lot when you're first getting started.
It is.
I struggle telling people where to even start. Besides, you just got to do it. You got to have the book for reference. Got to have the documentation. You got to just do it. It's hard to get past that.
It is. It's a super challenging thing to teach. When I'm on the speaker circuit talking about these things, the number one question I always get at the end is, well, one of the scenarios that I'm explaining is, here's how you walk the heap in order to be able to figure out heap corruption. And the question at the end of it is always like, well, is there a cheat sheet for the WinDbg commands? And I'm like, the commands, literally, remembering the commands is the easiest thing you possibly do. Understanding what the commands tell you is what the really hard part is, because you have to understand a lot of things, right? So it is a hard thing to teach, for sure. And especially if you do like a breakout session for an hour or so. Like if you have a solid 3 days workshop type of a thing, I think it's a little easier to make it sort of click for people. Like, all right, it's not about the commands; it's about what's happening under the covers.
Yeah, I stopped doing those intro sessions because it's just you don't even you really have to do things that are specific to a scenario, or a longer session, like you said. I think that works better. But
and to be fair, like there is nothing. I'm not saying anything bad or anything about doing an hour session and people asking about that. We haven't made it easy enough in these scenarios for it to be digestible in an hour. And maybe some of the things that we were talking about we can do a lot better moving forward. But certainly it's not an attendee's fault for not getting it in an hour. Right?
It's a broad topic, and the some of the tools, WinDbg included, are arcane to get started with, for sure.
I might be able to teach someone how to change oil in an hour, but can I teach them how to rebuild an engine in an hour? I mean, probably not, right? So
there's certain things that I think are just really hard to teach without having the experience. I wrote a blog post I think a couple months ago that I just thought was going to be a funny little side note, that was recognizing patterns in memory. And there's just some weird little tricks that I think a lot of folks that have been staring at memory windows for a long time, I think some of them pick up these tricks without even thinking about it. And a lot of people have just found that really interesting, about how you can look at some bytes and see like, oh, I see some bytes that are starting with a 4. Well, I think that's x86 code, because that's a really common x86 prefix. That's not something you can ever even, like, you can sort of teach it, but it's not something where you're even going to know where it's a useful thing to know unless you've just had that experience. And so I've been trying to write about some of these things just because I think they're interesting to people, of trying to capture some of these weird little, I want to say trivia, right? And it's not going to be useful for most people. But maybe somebody's going to remember and be like, "Oh yeah, I remember there was this weird little thing that I read."
No, I think it's super useful. Being able to, not necessarily like, here, memorize patterns, but here's why pattern recognition is important, right? So I think that's super cool. Here's kind of a funny story though. For Advanced Windows Debugging, the cover of it has a magnifying glass, and he's got some memory dumped behind it. After all this time, no one actually has decoded what's behind that magnifying glass. So whoever's watching and has read that book, speaking of pattern matching, feel free to try to decode that.
Oh, that's funny. Before I publish this, I'm going to go and I'm going to do it first.
I mean, really, it's a really, I love diagnostics and debugging. I think the future, there's a lot to be excited about. And like I said, in terms of the hardcore debugging, I think that's it's evolved, but it's kind of stayed the same. But with the AI and LLMs and all these things, I think I think um, we can all think about how can we make that experience better using that technology, and how can we make it more efficient. So, how was the well? Now I'm going to ask you a question.
Sure, go for it.
How was the experience? When we're talking about over the years, how in terms of the hardcore native debugging scene is it evolves, but it's evolves perhaps a little bit slower and it's a little more challenging. Like, how was it for you when you were envisioning WinDbg next, um, and the things that you wanted to explore and do in terms of sort of getting that out the door?
Yeah. So it's interesting. WinDbg Next was being created and it was evolving kind of at the same time as some other things in the debugging space, and they definitely influence each other. And so, sort of in the core debugging engine functionality was where we were doing things that we call the debugger data model, where we were doing better scripting and better, visualizations of things. And on that side of things, what we were really trying to do was get rid of some of this first level of not looking at raw data, not looking at like the fields of an STL structure, for example, right? Not looking at the raw things, and trying to give that first level of analysis and put that at people's fingertips. And on the WinDbg side was on the WinDbg Next side, when we were thinking about new user interface, was really about how can we've got all this power, we've got all this information. How can we put this in front of people in a way that is it's there at the right time, right? We always struggled with, um, there's 1,000 commands, right? There's 10,000 commands, um, and getting past that, like that was the core strength of WinDbg, was all of those commands, but it was also its biggest weakness. And so everything we were doing at that time was, I think, motivated by and informed by that, which was we have all this power, we have all this functionality, but if it's not usable, or if it's only usable by the expert in the memory manager who's been doing this for 30 years, then it's not really, we're not having as much impact as we could be having. And so everything around what we were doing and how we were evolving it was trying to move in that direction. And it's a hard problem to crack, right? But doing things where where we said, hey, we know that when this structure is in the watch window or in the locals window, here's the extra information we're going to show you. We know that when you're debugging on this stack frame, here's the things that we want to show you. And I think that was one of the key things that was informing both sides of that evolution. And that was a pretty big chunk of time that was a really major thing that was kind of driving us, was that getting the right information in front of people. And I think we succeeded to a certain extent, and there's still more that can be done there. Like we were talking earlier, there's so much information available, and when the information you actually need is a small fraction of that, trying to get people to that information faster. And I think that was just always in our minds, is like streamline getting to the information, right? And we had some, I won't say missteps, but we had some moving in sideways direction in terms of trying to get things easier for people to use. And I'm happy and proud with what we ended up with, but there's so much more left. I was kind of sad to leave. I left Microsoft in January, beginning of January, and it was bittersweet because I had all these other things I wanted to be working on, and doing. Um, and I'll still I'll still go and work on some of the samples and try to, you know, test WinDbg and stuff like that. Sometimes it's still not completely gone for me, but
No, I mean, this WinDbg next was phenomenal, right? Um, not in addition to what you were saying, like in terms of making the data more presentable, um, and we have 5,000 commands. Just even the small things like go up and say, I'm starting a new debug session, and what I want to do is I want to get a time travel debug trace for this process. You select the
yeah,
process, and it's a checkbox. It might seem such a small thing, but if I have to go back because I don't use necessarily time travel debugging every day, I have to go and figure out what are the switches, what are the options, what are this, how do I do that? Like having that thing there and just clicking open is amazing.
yeah,
Um, and the the scenario as I'm explaining it, like it doesn't seem like a big thing, but it really is. Like having those type of things in there makes all the difference to our customers, I think.
yeah. That was one thing, where just the fact that we had moved to a more modern toolkit, more modern set of languages, um, there were all of these low hanging fruit that was, oh, this used to be run 15 commands in the command line and do this and do
Yep,
that. And now we can replace it with a checkbox. That was always, those were the most fun to do because, it
it's a big
wasn't,
impact.
yeah, yeah. In terms of the amount of impact that we had for the amount of work we did, it was always amazing. Um, those were great, right? Automating your kernel setup, automating time travel debugging, tracing, and stuff like that. The one that I wish that we had gotten to that we never really got around to was more of these like hidden debugger flags, things like loader snaps,
Mm.
things like some of the attaching to the next instance of a process, things like IFEO that people just if you don't know about it, you don't know about it. You don't even know to look for it, right? And I wish, and I'm sure, it's not like the project's done. There's still people working on it. So if anybody in my old team is listening, there's still some good things to work on. But there's just so many of these little things that, if you don't know it exists, you're not going to know to look for it. And like the checkbox for TTT, right? Um, at the same time, though, it's like you don't want to flood people with options. You want to
Right.
find those ones.
Yeah.
Um, yeah, I appreciate all the time that you spent talking with me
Oh
today.
yeah. No, it's been fun.
Yeah,
Going back down memory lane as well, and thanks for having me on. Um,
yeah. Thanks so much for talking with me.
yeah.
It's been really great. I'm sure people find some of the stuff that we were talking about should be interesting. And now I feel very motivated to go and try more of the Sysinternals tools on Linux.
Yeah, no, do it. We, like I said, we want all the feedback that we can get, and not just the tools that are there, but if you feel that there are, other sort of tools that um, could benefit from it, then let us know too. They're all
Yeah,
open source, so they're all on GitHub.
yeah, that's great. That's awesome.
Yeah,
Well, again, thanks so much for talking with me. Thanks everybody for watching. I'll put a link to Mario's Twitter handle. You can go and send him feedback, and I'll put a link to some of the sysinternal stuff as well that we were talking about. Yeah, hope you all enjoyed this.